This video is a quiz review for Expo. We are looking at the 8.1 to 8.4 sections of Chapter 8. First part, why are each of these not in standard form? So standard form means biggest exponent to smallest exponent. So this one, the one on the left, has to have the 6x to the third written first, then the next biggest exponent written second, then the constant written last. Okay, this one over here is not in standard form because these are called like terms, which means we can combine them. So we have 2 and 5 that we can combine into 7, x squared minus 9. This one is now in standard form because x squared is the biggest exponent, and we have that written first. So naming these by their degree and the number of terms. So the first part here is naming it by degree. So if the biggest exponent is 3, 2, or 1, we have names for that. We also have 0. If the biggest degree is 0, it's just called a constant. Okay. Then we have some names for how many terms there are. There's always nomial at the end. It's just a matter of which kind of nomial we have. So the one that's up on the left here, the biggest exponent is 3, which makes it a cubic. And there are 3 terms, which makes it a trinomial. The biggest exponent for the second one is 2, which makes it a quadratic. And then we have a binomial. There are 2 terms. So that's just a little bit about naming. Next, we have combining like terms, so adding and subtracting. So trying to find the mistake, the first one says, what's wrong with this? So as I'm looking through, we're adding these exponents, or sorry, that's the mistake. So we're adding these polynomials, but when we do that, we're adding the coefficients. We're not supposed to do anything to change the exponents. So if you look at 3x squared and 4x squared, those are like terms, which means we can add the numbers in front. But when we do that, we keep the exponents the same. So we're not supposed to change the exponent. Here, they said that 3x squared plus 4x squared is 7x to the fourth. What they did is they added these 2's. We're not supposed to do that. And when you add or subtract polynomials, you never change the exponents. So that's a mistake, and so is this next one then. Because we have a positive 2x and a positive 3x that can make positive 5x, but we're not going to say 5x squared. Then they didn't make a mistake with the last part. Negative 1 and positive 5 make positive 4. When you add and subtract polynomials, leave the exponents alone. Don't change them. With more than one variable, this always makes people a little bit less confident, but this AB to the 3 matches this AB to the 3. So it doesn't matter that there's more than one letter. Since those are a perfect match, I can add the numbers in front of those. So 4 and 5 make 9, and I'm leaving AB to the third exactly the same. C matches C, so I can take the 3 and the negative 2, and I can combine them into 1. You can write the 1 in front if you want, like this, 1C, but you don't have to. You can just leave it as a C with nothing in front. If there's more than one letter, nothing changes. As long as the bases are a perfect match, you can add the coefficients. Okay, here's another mistake. So what's wrong with this? So when we subtract, remember what we wanted to do was we wanted to distribute the negative into everything, and we wanted to write it as a plus problem. When we do that, we can turn this into a plus, but we have to take the opposite sign of everything inside the parentheses. So I'm willing to bet that's where the mistakes are. Okay. So when we're looking at 4x to the third and negative x to the third, that is supposed to be 3x to the third. So this one is correct. We have a 3x squared in our answer. So we don't have any x squareds on the left, but we have a positive 3x squared, or I'm sorry, a negative 3x squared on the right. So there should be a negative 3x squared in our answer, but this says positive 3x squared. So that looks like a mistake right there. So this should have been negative 3x squared. I have 2x and positive 3x. Positive 2x and positive 3x should have been positive 5x. So there's another mistake. And then negative 7 and negative 1 should have been negative 8. So there's another mistake. So it looks like what they forgot to do was distribute the negative. And if you don't distribute the negative, you run into all kinds of problems. So let's just go through again what the right way would have been. We made this a plus problem, and we changed the sign of everything on the inside of the second parentheses. Okay? So then now we know we have some like terms. 4x to the third goes with negative x to the third. 4 minus 1 is 3. Leave the exponents the same. The only x squared term is negative 3x squared. I have a positive 2x and a positive 3x. That gives me positive 5x. And then I have negative 7 and negative 1. That gives me negative 8. So that should have been the answer. When you subtract polynomials, you need to distribute the negative. Okay, perimeter word problem. The perimeter of a triangle is 10x plus 7. They're going to give us almost enough information. They're going to give us 2 out of the 3 sides. So 2 of the sides have the following lengths. One of them is 3x plus 1. One of them is 5x minus 2. What is the length of the third side? So this is like the question mark. Okay. How we find perimeter is we add up all 3 sides. Okay. So we add all sides together. So here's what we know. We know that the total is 10x plus 7, and we know 2 things that got us to that 10x plus 7. So remember, this had 2 steps when we did this. We're going to add the given sides first. Then we're going to have a subtracting step, okay, where we subtract from the total. So that'll be step 2. Step 2 is going to be subtract from the total. Well, I'm just going to say perimeter because that's the better way to say this. So step 1 is going to be add up the stuff that we got, add up the stuff that was given. So that's 5x minus 2 and 3x plus 1. Okay, this is already a plus problem, so I just need to worry about like terms. 5x goes with 3x, 5 plus 3 is 8, leave x the same. Negative 2 and 1 make negative 1. So this is not an answer, but what this 8x minus 1, is the total of 2 of the 3 sides. So what I'm going to do is I'm going to take that and I'm going to subtract it from the perimeter. The perimeter was 10x plus 7. So we have 10x plus 7. We want to take away 8x minus 1. So I'm going to distribute the negative into both. We have 10x plus 7. Now we're going to write it as a plus problem. Negative 8x, positive 1. When we do that, we have 10 and negative 8 that go together. So we have a 2x. And then we have 7 and 1 that go together, positive 8. So the answer must be 2x plus 8. That would have to be what that third side would be so that the perimeter is 10x plus 7. Okay. And then we got into multiplying polynomials. So sometimes that means distributive property, sometimes that means FOIL, which still is distributive property. So if there's only a monomial, so that's just one term, outside, what we do is we distribute it to everything on the inside. So 3x has to get multiplied by 4x squared, and 3x has to get multiplied by 5x, and 3x has to get multiplied by negative 3. Okay, so when you multiply these, you can multiply the coefficients. 3 times 4 is 12. Now we're adding exponents. We have x and x squared. That gives us x to the third. 3 times 5 is 15. X times x is x squared. and then 3 times negative 3 is negative 9, and then we have x attached to that. So that would be how we use distributive property with a monomial. Okay. Next one, it's a binomial and a binomial, so we have to FOIL this. Okay. FOIL stood for first, outside, inside, last. The first terms are x times x, which is x squared. The outside terms was x times 7, which is negative 7x. The insides are 3 times x, which is 3x. The last terms are 3 times negative 7, which is negative 21. Okay. When you do a FOIL problem, check if the O and the I, the outside and the insides, combine. This time they combine to negative 4x. They were like terms. So we can write our final answer, x squared minus 4x, combining the O and I, and minus 21. That's called FOIL. We'll FOIL the next one too, but this one's kind of a special type of FOIL, this lower left. We have exactly the same set of binomials, except for one of them has a plus sign and one of them has a minus sign. What happens with this is the middles drop out. You can FOIL this. There's also a little bit of a trick to these, but let's try FOIL. Okay, 2a to the third times 2a to the third. Okay. What that would give us is 2 times 2, which is 4, a to the third times a to the third, which is a to the sixth. Outsides would be 2a to the third times negative 5b. Okay, there's not going to be a lot that we can do right there. We can do the negative 10, and then we can just do a to the third b. Okay, insides is going to be exactly the same thing. We have 5b times 2a to the third. The only difference here is we don't have a negative. This is a positive 10, and I'm going to write a to the third b again. Just write it in the same order. And then we have last 5b times negative 5b. 5 times negative 5 is negative 25. b times b is b squared. What happens with these is these go to 0. A to the third b, which is 0. So the middle part, these are going to cancel out. So if you have the same set of parentheses, but one is plus, one is minus, your answer is only going to be a binomial. We keep the first terms, we keep the last terms, everything else cancels. And then the last one I'll remind you about like this is we have to remember we cannot do distributive right here. That does not work. What 2x minus 5 parentheses squared means is that there are 2x minus 5s, 2 sets of that parentheses. And then now it's a FOIL problem. Okay? So distributive property does not work as soon as there's a minus sign. So we have 2x times 2x, which is 4x squared for the first terms. The outsides, we have 2x times negative 5, negative 10x. Insides, we have exactly the same thing, negative 10x. L times L, we have negative 5 times negative 5, which is 25. These are like terms. They add to negative 20x, so our answer is 4x squared minus 20x plus 25. Okay. Then we have these area problems. Okay, it says you know how to find the area of both squares. So how do you get just the shaded region? So the way that we do this is we take the big square area minus the little square area. So what that will look like, to get the big square area, that's x plus 2 times x plus 2, the big square. Okay, x plus 2 times itself. Okay, the little square is x minus 1 times itself. So what we're going to look to do is FOIL here. So when we FOIL this, we get x squared, we get 2x, another 2x, and then 2 times 2 is 4. That's the first one. This one FOILed, we get x squared minus 1x minus 1x plus 1. Okay, so when we do that, x squared 4x and 4 minus x squared 2x and 1, what happens is we're trying to now subtract these two polynomials. To do that, we turn it into a plus problem. We distribute the negatives. So we have negative x squared, positive 2x, and negative 1. So what's going to happen here? Our x squareds are opposites. They're going to cancel. We have a positive 4 and a positive 2 that make positive 6. We have a positive 4 and a negative 1 that make positive 3. So that's the area of the part that's shaded in. So you FOIL them both, you subtract them. When you subtract them, you have to be very careful about negatives. Subtracting negatives. All right, I think this is the last one. Yep, so factoring. GCF, remember that stands for greatest common factor. What we're looking to do is find something that all of the terms have in common, and we want to pull the biggest common factor out front. Okay, then we're going to take the number that divides all the coefficients and the smallest exponent of the variable they all have in common. Okay, so for numbers first, we have 4, we have 16, and we have 12, negative 12. 4 goes into all of those. So I'm going to just write the GCF first. I know 4 is part of the GCF. 4 goes into all of those. And then x goes into all of them. Specifically, they all have at least an x squared. So we're taking that smallest exponent and putting that into the GCF. So when we factor this then, we put the GCF out front. We divide everything in the original equation by the GCF. So 4 divided by 4 is 1. X to the 4th divided by x squared is x squared. We're subtracting those exponents. 16 divided by 4 is 4. X to the 3rd divided by x squared is x to the 1. And then negative 12 divided by 4 is 3. And we are taking all the x squareds out of that. So here would be the factored version of that problem. All right, hope that video helps. We will be looking at this and taking a quiz on this on Monday. We'll see you then.